Hello students, today we will discuss about JEE Mains 2015 physics paper. Now we will discuss all the questions one by one. Okay, let us start. Hello students, let us move to the next question. The question is about the moment of inertia from a solid sphere of mass m and radius r. A cube of maximum possible volume is cut. Moment of inertia of the cube about an axis passing through its center and perpendicular to one of its face is. So let me explain this first. Suppose that I have a sphere, solid sphere, and I cut a volume, a maximum possible volume. So I have to cut the maximum volume of a cube. So I'll cut a cube like this. So from this sphere I cut this cube. So obviously for this cube I will this is a cube, this is two-dimensional, it seems two-dimensional. I'll draw the three-dimensional picture of this, but you have to remember that this is the center of the sphere and this is also the center of the cube, and this distance for a sphere it is the twice the radius, that is the diameter, and that is also the body diagonal of the cube. So that means the diameter of the sphere is the body diagonal of the cube. Body diagonal of cube is 2r. But then this cube I will draw here. Suppose this is a cube that is cut from here. This is the cube, and suppose this is your x and this is your y and this is your z axis. Okay, and this is your y. So this is a cube. This side is y, this is x axis. So now what happens is that you have to find the moment of inertia about any face perpendicular to the face. This is a cube like this, and then suppose it's a cube. You have to find the moment of inertia about this axis which is passing through the center and perpendicular to the face. So the axis goes through like this. So about this sphere will rotate, the cube will rotate like that. Suppose that the side of which is A, so the volume of cube is A cube, the volume of sphere is 4 by 3 pi r cube. So now we have to find the mass of this cube. Suppose the mass of this cube is m dash. So what you are asked is moment of inertia about this axis. So axis is actually like this. The axis is like this, passing through like this. So about this axis we have to find the moment of inertia. Now you can see that if I have a cube, then that distance will be how much? So in case of a cube, I have to find this diagonal distance, which is 2r. But how to find the diagonal distance in terms of this side A? This side is A, this is A. So this distance is root 2a, and again this is A. Then this one you have to find. That means what? First of all, that means the face diagonal is basically the face diagonal you have to find, this one. Then you have to go up like this, and then this distance is this distance. So therefore first I'll find this, which is A and A, then I have to move up by A. Okay, so this point and join this point, that is the body diagonal. Now A, then this will be root 2a. then I'll move up by a. If I move up by a, then root 2a and a will give you this. That means root 2a and move up by a. Suppose this is the direction, then a, this will give you the vertical. This is root 2a, then this will be root 2a square plus a square under root. That comes out to be, this is 2a square plus a square root, that is 3a square root. This one is 3a square root. So this body diagonal, this distance is that is 2r, comes out to be this, or I can write 4r square, squaring both sides is 3a square. So this is one relation which is useful, that we will use, that whenever a is asked, we can write a in terms of this r. Now if I have a cube, I have to find the moment of inertia about this axis passing through center and perpendicular to one of its plane. Then this cube, I compress it, it will become plate. If you compress it, it will be plate. So I'll compress it, it will become plate. Then the moment of inertia is not going to change, okay, because the dimensions which is parallel to the axis, if it expands or shrinks, the moment of inertia is not going to change. Therefore, so this I will do that x and y, the z, the x, that is length, breadth and height. The height part I reduce because I will consider the axis passing through center end which is parallel to this height. So the height I reduce to 0. So when you reduce the height to 0, only you have length and breadth. You have a reduce to 0 means very minimum. So it becomes a plate. So it becomes a plates of side A, and A will be there obviously. Or I can say this is x and this is y. That you can keep, no problem with that. Then supposing this is your x and this is your y, then moment of inertia about this is z is asked. So moment of inertia about this, required moment of inertia about this is equal to the sum of moment of inertia about ix and iy. Then what about this ix? About ix, I will shrink this line which is parallel, this dimension is parallel. I will shrink this, it will become a rod. It will become a rod. So this is about, so the rod of length a. Similarly about this axis, I will shrink the axis parallel to this, the side dimension parallel to this I will shrink, and it will become a rod like that. It will become a rod like this. Okay, by shrinking this dimension, this will become a rod. So this is about iy, and this is about ix. But then about this same axis you have to consider. So then about this axis, it is if I saying this is length a. Also this side is a and also this side is a, because it's a cube, so its face are same. So it seems that a and a are different, but they are same because each side is same for a cube. So therefore about this axis, if I shrink which dimension about the, so about this axis, it is m l square by 12 like that. So for a cube, when it becomes a plate, the moment of inertia about this is the sum of the moment of inertia about this axis and that axis. About this axis, that is about the this line, about this line, it will be only about the rod you have to find. There is ml square by 3. Then I will consider about this axis and this axis, then it is ml square by 3, but my axis passes from here and here, where I will consider the axis passing through this. So this dimension which is parallel is like that, so this is ml square by 12, and that is also ml square by 12. So this will become ml square by 12, and the breadth is also b square by 12, but length and breadth are same, so it is a square by 12 plus a square by 12. So this is ma square by 6. So this m is now ma square by 6, but here the m is not the m in the question, this is the mass of the sphere. This is not the mass of the cube that is cut. The mass of the cube is something else. So this is the mass of the cube that is cut, and that we have to find the mass of that cube. Then proceed further. Next is, this is the answer to this question, but then we have to write this all. So the answer to this question is ma square upon 6, where m is this, m is the, suppose I will call this as the m dash. So m dash is the mass of cube, and we'll write the mass in terms of the mass of the sphere. Then mass per unit volume will be same. This mass and its volume, the whole mass of the sphere and its volume must be same. So from here, this m dash comes out to be 3 ma cube upon 4 pi r cube. So I'll substitute here. First thing I'll substitute this. Then next is, what about a? Now already I told you that the 4r square is 3a square here. 4r square is 3a square. Here a square is required. So a square I'll put as 4r square divided by 3. If I substitute this a square as this value and m dash as this value in this expression, then what I'll get? I'll get I equals to the moment of inertia of the cube about the given required axis is m prime, which is this value 3. I'll write here 3m a cube upon 4 pi r cube cube, and then a square. A square is here is a cube also there. So first I'll write a square. A square is 4 r square upon 3, and 6 is also there. So 1 by 6. Okay. Now, so from here I'll cut. So this is the total picture. Now from here I'll cut 4. I'll cut 3. So it is m, and I will cut r square. So it will become r. So it will become m a cube upon 6 r pi 6 pi r. Again I write a cube. So from here, what will be a cube? From here, a equals to 4 by 3 r square root. So this is 4 by 3 on the root into r. So a cube will be 4 by 3 on the root into r cube. Substitute this value here. I will get m upon 6 pi r, then 4 by 3 root into r cube. So this will cut and r square is left. So the answer to this will be this 4 is there. So 2 2s are 2 3s are. So 2m by 9 pi, 2m by 9 pi, 2m by 9 pi, and 4 by 3 root r square, which is 2 can that can be taken out. So first we have to see the options. So what are the options? So if you see the options, then I will take this 2 also coming out. Then this will be 4m r square also there. 4m, this will be 2, so 4m r square divided by 9 pi root of 3. 9 pi root of 3. So 9 root 3 pi, that means 9 root 3 into pi. If I see the options, you can see 4m r square, 9 pi root 3, So therefore, the option number 3 is correct answer to this question. Okay, thank you.